Hey guys, today a look at the Wii Wireless Sensor Bar that runs on 4 AAAs, and as you can see here, it works pretty fine. If I move the sensor bar, it also moves on the screen, and specifically what happens, it is basically a little button with 3 LEDs on each side that imitates the sensor bar that you have on your Wii. And what I like about it, it runs on a really rundown cells, and you can actually use your old cells to run your sensor bar to, basically run into the ground. And you can always adjust it. I have it at the top because from what I noticed, it's not as bright on a rundown cells that have only 1 volt each, so it's better, but it's a better idea to run them at a high sensitivity. So let's take a look at it and disassemble it. Here is specifically what you get. It's actually very similar to a sensor bar. It's completely black. I chose this version because it matches my TV. There is also a silver version, and it has a single button to power on. All you can personally see is exactly what you see on the camera. So if I use my phone for this and I'll turn off most of the lights, you can see the LEDs on each side. So if I move the bar around, this is the middle and this is the right side of the bar. What you also get in a box is this transparent stand with a double-sided tape that you can put on your TV, and it basically launches into those holes just fine, and it will provide a support so you can stand it off the TV. It all runs quite well, and you have a single latch for your batteries. It needs 4 AA's, but from my experience that can be really run down. And as you can see on the bottom, all you have are 6 screws, so let me remove them and let's take a peek inside. Okay, so it only has some latches, and as you can see here, it is very simple. All you have on both sides are those LEDs, and here even each of the LED sets has its own resistor, and let me measure that and quickly draw to you a diagram. So here's the diagram. I did some tests, and what you have here is 6 volts from 4 AAA cells, and then you have a few circuits in what's basically is a parallel. And here in series, that's a 1 circuit, that's a red LED. It has a single 680 ohm resistor, and those 2 circuits are exactly the same. There are 3. They are in that exact order, which is a little bit weird, but it works out on the board. 2, then a resistor, and then 1, so 3 infrared LEDs and a 22 ohm resistor for each of them. So each of the circuits, so this one, and this one, this is run at 5.9 milliamps, this is run at 88.6 at the 6 volts, and this again 88.6 milliamps around. I mean, I'm just doing a rough calculations here, which more or less, if you add it all up, it's around 183 milliamps at 6 volts, which would mean that those 4 cells will last you around 5 or 6 hours on a standard AAA cells. That's a battery, not a rechargeable cell. So it's not great, to be honest, but the voltage over time will drop significantly, so everything will drop really quickly to be, and here you would have around 4 volts over the time. So I would guess in reality around 8-9 hours of battery life for this. One thing I can mention also, there is a drop of 1.8. I calculated for 2 volts, so it's a little bit bigger. It should be 4.7 milliamps. So 1.8 volts of drop on the red LEDs, and 1.3 around, a little bit over that, for each of the infrared LEDs. And there are also drops because the internal resistance of the battery, this isn't a perfect power supply, so it won't actually work at the 193 when you measure that in circuit. That's the, let's say, ideal circuitry. In reality, you would have a bit better battery life because they are also relying on this, on the flames, the cables, and the internal resistance of the batteries. But well, 9 hours isn't that great? That would explain a lot why Nintendo actually went with a wired one instead. So this is what you get exactly with a wireless sensor bar. That's a really simple circuit. Thank you so much for watching, and see you guys next time.